Welcome to Chapter 3, our fourth and final part for acids and bases. Lewis acid and base theory is something you were probably introduced to in Gen Chem, and it just extends our definition of acids and bases, right? Arrhenius was very limited. We talked about acids and bases only in terms of ions produced in aqueous solutions. Bronsted-Lowry allows us to talk about acids and bases more broadly as proton donors and acceptors. Lewis now allows us to talk about acid and base reactions even if there is no transfer of a proton. So Lewis acid-base definition, very important. I'm not going to rewrite it because it says it right here. A Lewis acid accepts electrons. A Lewis base donates electrons. Right? So as opposed to a Bronsted-Lowry acid, right? So I'm going to very simply go with the reaction they looked at the bottom of the slide of water and hydrochloric acid, right? This is our Bronsted-Lowry acid and our Bronsted-Lowry base. And we see that the water is accepting the proton and the HCl is donating the proton. But another way we can look at it is as a Lewis acid and base. Bronsted-Lowry bases are also Lewis bases. Instead of thinking about it as accepting the proton, think of it in terms of this lone pair of electrons. It's donating those electrons. It's now going to be sharing those electrons. And then your Lewis acid is accepting those electrons, right? And that's still going to give us our conjugate acid-base pair. There we go. It's just a different way to define it, right? So instead of the proton, we're looking at the electrons. That allows us to extend our definition of what can be considered an acid-base reaction. Consider water interacting with or boron trifluoride, right? There is no proton being donated or accepted, but you are getting a similar type of reaction where the electrons in the water are still being donated, right? So it is a very similar process to what we saw in that Bronsted-Lowry acid-base step up above, but we couldn't think of it in terms of acids and bases if we were focused on the proton. But it is still the donation of those electrons from the oxygen, and the boron is accepting them. Now, in this case, there is no proton being broken off, so we aren't going to see a second arrow. There's no bond breaking, and so we wind up getting this cool little complex between the water and the boron trifluoride, and you just wind up with a positively charged oxygen and a negatively charged boron. It fits Lewis, right? So this is your Lewis base still, and this is your Lewis acid, but it would not be considered a Bronsted-Lowry base or acid. It is important to remember when acid and base is used without kind of the defining name, it's talking about Bronsted-Lowry. But we will use Lewis acid and base theory periodically throughout this year. There are some reactions that rely on Lewis acids that we're going to learn about later. So it's important that we know the name and we know the definition. So it's really important that you know the Bronsted-Lowry definition versus the Lewis acid and base definitions, and that you can identify them, right? This probably could have been included in the last lecture. You're welcome for a very short Chapter 3, Part 4. Practice identifying Lewis acid and Lewis base in the examples in your homework and found at the end of Chapter 3 in that 3.10 module. All right, I'll see you in Chapter